Hello everyone, welcome to AlgoKnights. We are a group of passionate undergraduate developers and we are here to help you understand computer science and information technology concept in a simple and practical way. In today's video, we're going to start an important topic called string matching algorithms. Before we jump into the algorithms, we first need to understand what string matching is, how it works, and an important concept called finite automata, which will help us understand string matching more clearly. And if you already know what string matching is and what finite automata is, you can just skip this video and jump straight into our next video. And if you are new to string matching algorithms, I highly encourage you all to watch this introduction part to get an idea about string matching and finite automata. So without further delay, let's get started. Right? So what is string matching? In computer science, a string. A string is simply a sequence of characters. So string matching means checking whether a smaller string, which is called a pattern, exists inside a larger string called the text. So our task is to find whether the pattern appears inside the text. So for example, let's take the word AlgoKnights is great. And we are looking for the text great, which is obviously available in the pattern. So our task is to find whether the word great appears inside the text and if it does, at which position. So this might sound simple, but string matching is used in many real-world applications like search engines and text editors and even in spell checkers. And sometimes in plagiarism detection. You can note this down if you want. Okay, so how does string matching work? At a basic level, string matching works by comparing the pattern with the text, character by character. Let's say we have a pattern. This is our pattern. And we have a text. So we start from the beginning of the text. We place the pattern under it. We place it here. We check if all characters match. We are going to check if all characters match. And if the characters match, we are going to continue checking. And if a mismatch occurs, we are going to shift the pattern and try again. And then let's say if a match occurs, we're going to move it here and we're going to check it, and here we're going to check it, and that's how it works. So this process continues until we either find a match or reach the end of the text. If we find the match, that's okay, that's good. And if we didn't find a match, if the pattern is not available in the text, we'll be reaching the end, and that will be the end of our string matching. So that is how string matching works. And let's move to our next part. So what if the pattern is not found? So guys, this is very important. Now, what happens if the pattern does not exist in the text? We have our pattern here, and we have a text here. So we're going to check whether this pattern is available in this text. And if the pattern does not exist in the text, in that case, the algorithm will compare the pattern at every possible position. So this is going to get compared in every position. And if no complete match is found, the algorithm simply concludes that the pattern does not exist. So this pattern is not available in this text. Let's look at an example. So we have a text, something like A, B, C, D. And we are looking for a pattern FG. So clearly, FG is not available in ABCD. So here, no matter what and where we place the pattern, the characters will never match. It's so obvious that FG is not available here. So this is not going to match with the text. The final output will be something like pattern not found. Not found. Simple as that. And the important point here, string matching algorithms, they do not crash or fail. So if the pattern is not available in the text, they just return that no match exists. That's it, guys. And let's move to our next part. Why do we need algorithms for this? For small strings, simple comparisons are fine. Let's say we get something like ABCD and we are looking for the pattern CD. We can easily compare these two and get the string matching done. But when the text is very large, like millions, billions of characters, let's say we have a character which is 10 to the power 9 or something like that. So when the text is very large, checking each portion becomes very slow. If we try to check a pattern in this text, it is going to be very slow. So computer scientists, they designed different string matching algorithms to make this process faster and more efficient. That's why we have string matching algorithms. Okay, now before learning string matching algorithms, we need to understand a very important concept called finite automata. What is finite automata? A finite automaton is a mathematical model used to recognize pattern in strings. So you might know what finite automata is. So it's something like what we have to do is eventually we have to build the transition table and we have to draw the pattern, something like this. You might have seen this. And finally, we are going to reach to the end. This is the end. And the transition table, of course. So I'm going to teach you a new way to find the transition table. It's a small trick, guys. So if you watch this video, if you watch this playlist, I can assure you that this trick is very easy compared to the traditional finite automata method. Like we find this pattern and then we draw the transition table. So instead of that, we can just find the prefix and then straight away we can draw the transition table. And once you draw this transition table, it will be so easy for you to draw this structure. I'll teach you how to find the prefix. And when we talk about finite automata, it consists of finite number of states and it moves from one state to another based on input characters. So now, for example, let's take a pattern here. The pattern is AB, AB. With this pattern, we are going to give the input here, and when we give the input A, it's going to go to 1, and when we give the input B, it's going to move to the position 2, and when we give the input A, it will be moving to position 3, and then B, it will be moving to the position 4. So that's how finite automata works. In simple words, guys, finite automata reads input one character at a time. If you can see here, it only reads one character at a time and changes its states based on rules. There are rules, I will explain the rules later. It decides whether the input is accepted or rejected. Let's say we are going to give an input B here. So obviously it cannot go to the position 1. So there are rules, and according to the rules, it will be rejected, or sometimes when the input is right, it can move to position 1. So we can discuss it later, and we'll move to the next part. And when we look at simple finite automata, let's say we want to check whether a string contains the word AB. So we're going to check whether a string contains the word AB, and we're starting from the state Q0, which is 0. And if the input is A, we will be moving to the position 1, which is Q1. And if the next input is B, we will be moving to the position 2, which is Q2, and this is our final state. So if we reach the final state, the pattern is accepted, and if not, the pattern is rejected. This is exactly how string matching works, guys, internally, by tracking progress through states. We call these as states, state 1, state 2, and state 3, and this is the initial state, Q0, and this is our final state. And we can move to our next part. Now, when we look at the connection between finite automata and string matching, in string matching, using finite automata, each state represents how much of the pattern we have matched so far. If we take something like this, now let's say we have the text here, that is A, B, B, and each state, it represents how much of the pattern we have matched. At state 2, we have matched AB, and at state 3, we have matched ABB, which is the final state, and at state 1, we have only matched the pattern A. So at state 0, we have matched nothing. So if a mismatch happens, the automata moves to another state instead of starting from scratch. This idea is what makes algorithms like KMP efficient, guys. We can look at that later. And right now, we can move to our next part, which is our homework. Guys, today's homework is quite simple. For each of the following cases, try to identify the text and the pattern. And there's a text and pattern given. Try to answer these questions and try to draw a finite automata for the pattern ABA. If you have any questions, visit the official AlgoKnights website and submit your questions through the Get in Touch form. And please post your answers in the comment section. Don't forget to like, share, and subscribe, guys. It really motivates us to bring more content for you guys. And thank you for watching, and I'll see you in the next video.